The CIA Triad is sort of a mainstay in cybersecurity, a centralized model for protecting data. It's used in just about every book you'll ever read on network security or data security or cyber security, information security. It's going to be questioned on every certification test you take about security. It doesn't mean Central Intelligence Agency. This is an acronym for 3 words that we'll introduce here in this video. The first one is confidentiality, the second is integrity, the third is availability. And you'll notice I made this triangle here around the word data because that's the thing we're trying to protect. If our equipment gets lost, gets trashed in some way, it's a few $100,000. Big deal. Our insurance is going to cover that most likely, and it's replaceable. But if we lose our data, if all of my customers' credit card numbers get put out there and compromised, my reputation is down the drain, and so that is more important to me. My company's secret data is more important to me than my computer equipment. So that's what we're really trying to protect when it comes down to it. The first one then is confidentiality. By definition, this is that data should only be accessible by authorized people or systems. Now, I said people or systems. There are times when it's people, right? Only HR should have access to the personnel records. The other production people shouldn't have access to other people's personnel records. But then there are other times it's systems. So, for example, I want my PayPal, the PayPal computers to be able to reach into my banking system in order to be able to transfer money. So those are 2 different computers talking to each other. So I give authorization by giving my credentials to the PayPal computers so that they can access my bank's computers. I could use the word entities or principles. Both of those are used in this field, but I will just say people from now on, and I want you to understand that we are talking about people or systems. So how do we protect confidentiality? Well, there are several ways, and these are just a few of them. One is through authentication, proof that you are who you say you are. This is usually done through some form of username and password. It could be biometrics or some other types of factors of authentication, but it's if I want to keep things confidential, I want to make sure that you are who you say you are before I give up my data. The second one then is authorization, access control lists. In other words, if you step into my restaurant and I look at your ID to make sure you are who you say you are, now I look to see if you're on the list. Should I let you in or not? So authorization is after authentication, and that's when we look to see what that person is authorized to look at. The third way we can keep confidentiality is through encryption, codes and ciphers, secret writing to hide data from unauthorized people, and then of course physical security, locks, guards, alarms, lighting, and so on. Next is integrity. Now, integrity is that data should not be altered during transmission, storage, or when it's in use. So from the time it's created to the time it's finally read, there should be no alteration of that data. Now, integrity may also include another concept called non-repudiation. Non-repudiation means that you cannot deny that you are the creator or sender of information. So in other words, we have some sort of traceability of where that data started. Integrity can include both malicious and non-malicious alteration. So it could be that somebody purposely alters data, or it could be that somebody just pushes the wrong button by accident and alters it. It can also be natural causes, data loss due to equipment, disaster events, a flood that ruins my disk drives and I can only get partial data back out of it, tapes that get too close to magnets and corrupt some of the data. That can alter my data. So this can also be things like disasters and equipment problems. How can I ensure integrity? Well, hashing is one way. Hashing is simply doing a mathematical formula on our data before and after. And if the mathematical formula checks, if it's the same before and after, then I know that the data hasn't been altered. Certificates is a signature system using a third party, so a trusted third party to control our data. And speaking of signatures, I've included the word signatures here, which is used in certificates, but in order to pull off these signatures, we actually do a sort of reverse encryption and hashing technique. We will get into that in a later discussion, not right now in depth, but is a reverse method of doing encryption in order to create a signature. It's kind of an interesting method, by the way. Physical security, again, locks, guards, alarms, and lighting, and so on, so that nobody can change our data if they can't reach our data in the first place. Finally, we have, oh wait, I have one more down here I forgot about, backup and recovery techniques. Since this could be lost due to equipment disaster events, good backup and recovery would allow us then to make sure that we can get our data back to its original form. Now, availability. Availability means that authorized users can access the data. In other words, they haven't been locked out from our data in some way. Again, availability could include malicious and non-malicious intent. It could be that some bad guy does a denial of service on our systems and therefore we can't get to it. Or it could be that somebody just pushes the wrong button and the servers go down. Availability, again, can include data loss due to equipment and disaster events and so forth. How do we ensure availability? Well, backup and replication. If my data is lost in some way, but I have a backup or I have replicated data, then I can access it. We could get into some interesting philosophical discussions about why we need so much backup and replication. Doesn't that say to you that we have a problem somewhere? We have a weakness that we need so much backup and replication? If our storage systems are not robust enough to be able to handle, well, I'm not going to get into that right now, but we could get into a rousing discussion about that. Authorization, access control. We talked about this under confidentiality, but again, availability means that the right people have to have the right authorization, the right access, in order to be able to get to the data that they need. Disaster recovery planning, again, this has to do with backup and replication. It may also have to do with duplicate sites or cloud services that have our data available as well, or that we can move into, that kind of thing. And then again, physical security, in this case, things like backup power, weather sensors, and so on. So that's the CIA Triad. Now, we don't really call it a CIA model. We call it a CIA Triad. I know I used the word model at the very beginning, but typically we don't call it a model. We call it a triad. Get to know this thing really well, because this is something that you will see over and over again throughout cybersecurity.